We are looking at the calculus of parametric curves. Specifically, in this problem, we are asked to find the points on the curve x equals t squared minus 8t plus 1, y equals t squared plus 10t plus 8, that have the following: a horizontal tangent line, and b, a vertical tangent line. Now, in order to successfully work this problem, we have to remind ourselves of a few important things. First, we want to remind ourselves that the slope of any tangent line is equivalent to the first derivative. And specifically, when we talk about the first derivative for a parametric curve, we are referring to taking the derivative of y with respect to t over the derivative of x with respect to t, where y and x are functions of t. Secondly, we have to remind ourselves that when we have a horizontal tangent line, the slope of that tangent line will be 0. And when we're looking for a vertical tangent line, the slope of that tangent line will be undefined. These are things we have to keep in mind when we go about working this problem. So, let's begin. We start by finding the slope of the curve. That is, we want to find the derivative of y with respect to x at any point along the curve, which is simply dy dt divided by dx dt. For our specific curve, we have that y is t squared plus 10t plus 8. Therefore, the derivative of y with respect to t, using our power rule and our sum rule, is 2t plus 10. The x function in our parametric curve is x equal t squared minus 8t plus 1. And the derivative of x with respect to t is simply 2t minus 8. Putting these back into our slope, we have that dy dt is 2t plus 10 divided by dx dt, which is 2t minus 8. And I see that I'm going to be able to cancel some 2's, so let me start by factoring out a 2 in the numerator, and then factoring out a 2 in the denominator. And that leaves me with the quantity of t plus 5 in the numerator and t minus 4 in the denominator after I cancel the 2's. So my slope is actually t plus 5 divided by t minus 4. So let me put that information right here. The slope of the tangent line is t plus 5 over t minus 4. Now, what must we do with that slope? Well, we are specifically looking for the places where we have a horizontal tangent line and reminding ourselves that's when our slope is 0. So let's go ahead and let's figure out when our slope is 0. Our slope will be 0 when our rational expression t plus 5 over t minus 4 is 0. And what does that mean? Well, how do we solve a rational expression equal to 0? Well, that's simply when the numerator is equal to 0. Or if I want to be a little more rigorous, I would cancel my denominator of t minus 4 by multiplying both the left side and right side by t minus 4. In other words, t plus 5 is equal to 0 times t minus 4, which is just 0. That is, my rational expression is 0 when the numerator is 0, and specifically, that's at the place where t is negative 5. The problem, however, doesn't ask for the t value. The problem specifically states find the points on the curve. And points on the curve we know have values x and y that depend on t. And so we just simply have to go back and find x and y. We do this by substituting the t equal -5 into the functions x and y. That is, x of -5 is -5 squared minus 8 times -5 plus 1. Specifically, that's 25 plus 40 plus 1, or in other words, 66. So our x value is 66. Our y value, when t is -5, is -5 squared plus 10 times -5 plus 8. That's equal to 25 minus 50 plus 8. And that's just equal to -25 plus 8, which is, I believe, -17. That means that the horizontal tangent line occurs at the point 66 for x and -17 for y. We repeat the same process to find our vertical tangent line, except this time, instead of our slope being 0, our slope has to be undefined. So where is it that our curve has a vertical tangent line? Let's see. We know what our slope is. All right, let me organize here. I'm getting a little out of hand here. I'm all over this whiteboard here. So part B is we're finding the vertical tangent lines, and that is we want to figure out where is our slope undefined. And our slope will be undefined when the expression t plus 5 over t minus 4 is undefined. But what does that mean for us? What does it mean to have a rational expression undefined? Really what it means is this expression will be undefined when the denominator is 0, right? This expression is said to be undefined when our denominator is 0. So specifically, we're trying to find where our denominator equals 0, because it can't be 0. If it's 0, it gives us a value that's undefined. But specifically, so now I'm getting my words all mixed up. But what are we looking for? We're looking for the places where our denominator is 0. And that's occurring when t is 4. So when t is 4, this rational expression is undefined, and that makes our slope undefined, which means we have vertical tangent lines. So t is 4 at, again, we plug it in to the x function. So t is 4, when t is 4, x is 4 squared minus 8 times 4 plus 1. In other words, 16 minus 32 plus 1, which is -16 plus 1, which is -15. And y, when t is 4, is equal to 4 squared plus 10 times 4 plus 8. In other words, 16 plus 40 plus 8, or 64, I believe. And therefore, we have a vertical tangent line at the point -15 for x and 64 for y. Not too bad.